In a situation where a wire is cut resulting in an electrical shock, several parties could potentially be held liable. Firstly, the roofer. Their negligence in damaging the wire directly led to the electrical hazard. Failing to take proper precautions or promptly report the damage contributed to the dangerous situation. Secondly, the electrical contractor or the homeowner, if they performed the electrical work themselves, could be liable for faulty wiring or improper maintenance contributing to the circuit malfunction. The failure to use appropriate grounding and protection measures may be considered negligence. Thirdly, Federal Pacific Electric, the breaker's manufacturer, could be held liable if the breaker failed to trip despite a significant current surge from the short circuit. A defective or non-compliant breaker could be a product liability issue. Fourthly, the homeowner, if responsible for electrical system maintenance and neglecting it, could be partially liable for resulting accidents. Failing to report electrical issues or hire qualified professionals could be considered contributory negligence. Factors influencing liability determination include specific facts, applicable building codes, and legal precedents in the relevant jurisdiction. The importance of proper grounding cannot be overstated. Grounding provides a low impedance path for fault current to return to the source, tripping the overcurrent protective device like a circuit breaker or fuse. A properly grounded system ensures that metallic parts of electrical equipment, such as appliance chassis or conduit, do not become energized in the event of an insulation failure. Without proper grounding, a fault current may find an unintended path to ground, such as through a person, resulting in an electrical shock. The National Electrical Code, or NEC, sets the standards for grounding and bonding electrical systems to ensure safety. Bonding is also crucial. Bonding connects all non-current carrying metal parts of an electrical system to create an electrically conductive path. This path ensures that all metal parts are at the same electrical potential. Bonding reduces the risk of voltage differences between metal parts, preventing electrical shock hazards. The NEC specifies bonding requirements for various electrical systems and equipment. Overcurrent protection devices like circuit breakers and fuses are designed to protect electrical circuits from excessive current, which can cause overheating and fire. Circuit breakers are reusable devices that trip and interrupt the circuit when the current exceeds the breaker's rating. Fuses are one-time use devices that melt and break the circuit when the current exceeds the fuse's rating. The proper selection and installation of overcurrent protection devices are essential for electrical safety. The NEC provides guidelines for selecting the appropriate size and type of overcurrent protection devices for different circuits. Arc fault circuit interrupters, RSIs, are designed to protect against arc faults, which are dangerous electrical discharges that can cause fires. RSIs detect the unique characteristics of arc faults and trip the circuit, preventing a fire. RSIs are required in many areas of the home, such as bedrooms and living rooms, to provide enhanced fire protection. Ground fault circuit interrupters, or GFCIs, protect against ground faults which occur when current leaks from a circuit to ground. GFCIs detect even small ground faults and trip the circuit, preventing electrical shock. GFCIs are required in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor receptacles. Wiring methods also play a crucial role in electrical safety. Romex, or non-metallic sheath cable, is a common type of wiring used in residential buildings. Romex consists of insulated conductors enclosed in a plastic jacket. It is important to handle Romex carefully to avoid damaging the insulation, which can create electrical hazards. Conduit is a metal or plastic tubing used to protect electrical wiring. Conduit provides physical protection for the wiring and can also serve as a grounding conductor. Different types of conduit are available for different applications, such as rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Electrical boxes are used to enclose and protect electrical connections. Boxes provide a safe and secure location for wiring splices and terminations. Different types of electrical boxes are available for different applications, such as metal boxes, plastic boxes, and weatherproof boxes. Wiring splices must be made properly to ensure a safe and reliable electrical connection. Improperly made splices can create heat and cause fires. The NEC specifies the requirements for making electrical splices, including the use of approved connectors and methods. Electrical panels, also known as load centers, are the main distribution points for electricity in a building. Panels contain circuit breakers or fuses that protect individual circuits. It is important to label circuit breakers clearly so that they can be easily identified in case of an emergency. Regular electrical inspections can help identify potential electrical hazards and ensure that the electrical system is safe and up to code. A qualified electrical inspector can identify problems such as loose wiring, damaged insulation, and overloaded circuits. Electrical safety training is essential for anyone who works with electricity. Training can help individuals understand the hazards of electricity and how to work safely. Electrical safety training should cover topics such as grounding, bonding, overcurrent protection, and safe work practices. Lockout-tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. Lockout-tagout involves disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch to prevent it from being turned on. Personal protective equipment, or PPE, is used to protect workers from electrical hazards. PPE includes items such as rubber gloves, safety glasses, and insulated tools. The type of PPE required depends on the specific electrical hazards present. The importance of hiring qualified electrical contractors is paramount. A qualified electrical contractor has the knowledge, skills, and experience to perform electrical work safely and in accordance with the NEC. Check the contractor's license and insurance to ensure that they are qualified to do the work. Permits are required for many types of electrical work. A permit ensures that the work is inspected by a qualified electrical inspector to verify that it meets code requirements. Contact the local building department to determine whether a permit is required for the specific electrical work being performed. Electrical codes and standards are constantly evolving to address new technologies and safety concerns. Staying up to date on the latest codes and standards is essential for ensuring electrical safety. The NEC is updated every 3 years to reflect the latest changes in the electrical industry. Always de-energize circuits before working on them. This is the most important safety precaution that you can take. Use a voltage tester to verify that the circuit is de-energized before touching any wires. Never work on electrical equipment when you are wet or standing in water. Water is a good conductor of electricity and can increase the risk of electrical shock. Avoid overloading circuits. Overloading a circuit can cause the wires to overheat and create a fire hazard. Use a circuit breaker finder to identify the circuit that is serving a particular outlet or appliance. This can be helpful when troubleshooting electrical problems. When replacing a circuit breaker, use the same type and size as the original breaker. Using the wrong size breaker can create a fire hazard. Regularly inspect electrical cords and plugs for damage. Damaged cords and plugs can create a shock hazard. Replace any damaged cords or plugs immediately. Never run electrical cords under carpet or rugs. This can trap heat and create a fire hazard. Use extension cords safely. Do not overload extension cords or use them for permanent wiring. Use surge protectors to protect electronic equipment from power surges. Power surges can damage sensitive electronic components. Be aware of overhead power lines. Never touch or come into contact with overhead power lines. Keep trees and shrubs trimmed away from overhead power lines. Call a qualified electrician if you have any electrical problems. Do not attempt to repair electrical problems yourself unless you are qualified to do so. Educate children about electrical safety. Teach them about the dangers of electricity and how to avoid electrical shock. Install tamper-resistant receptacles in homes with young children. Tamper-resistant receptacles have a built-in safety mechanism that prevents children from inserting objects into the slots. Consider installing a whole house surge protector. A whole house surge protector can protect all of the electrical equipment in your home from power surges. Use a qualified electrician to install a backup generator. A backup generator can provide power to your home during a power outage. Follow the manufacturer's instructions when using electrical appliances. Improper use of electrical appliances can create a safety hazard. Unplug electrical appliances when they are not in use. This can save energy and reduce the risk of electrical shock. Be careful when using electrical appliances near water. Water and electricity can be a deadly combination. If you see a downed power line, stay away from it and call the power company immediately. Downed power lines can be extremely dangerous. If someone is in contact with a live electrical wire, do not touch them. Call emergency services immediately. Use a non-conductive object such as a wooden broom handle to push the person away from the wire. Learn CPR. CPR can save a life if someone is experiencing an electrical shock. Take a first aid course to learn how to respond to electrical emergencies. Be aware of the signs of electrical shock. Symptoms of electrical shock can include burns, muscle spasms, and unconsciousness. Electrical safety is everyone's responsibility. By following these safety tips, you can help protect yourself and others from electrical hazards. If you have any questions about electrical safety, contact a qualified electrician. Remember, electricity is a powerful force that must be treated with respect.